we had this issue where gas nodes were getting DDoSed by transactions. There was a research group who came out with a paper about different attacks on the gas transaction pool. We fixed some of them and some of them we didn't. Someone saw this paper and started attacking gas nodes because Nethermind has implemented the transaction pool in a different way. They couldn't be attacked. Everything still worked fine. We would still create blocks and Nethermind would create.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on mev.io. And Composable. Execute any intent on any chain, coming soon to mantis.app. That's mantis.app. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%. GM everyone, my name is DeGatchi, the host of Scraping Bits, and today I have Marius from Geth development team. How's it going?
Going good. Thank you for having me on.
Thank you for coming on. Just for the people that aren't familiar with who you are and what do you do?
Yeah, my name is Marius. Been working at the Ethereum Foundation for 3 years, a bit over 3 years now. I started in the beginning of 2020. And I'm working on the Geth team or Go Ethereum team, doing kind of everything that needs to be done. So there are some people in the Geth team that have like specific roles or like they have a specific part of the code they're working on. But I'm looking at everything that I can find. So I did a bunch of fuzzing in the past, worked a lot on the merge stuff. Yeah, so that's kind of me.
Interesting. So you kind of just do everything really and not a specific part.
Yeah, I'm very interested in performance and making Geth better and faster. I kind of look into every package and see if there's something that can be done there and do odd jobs around the code.
How did you actually get into this stuff? How did you get into crypto? What were you doing before it? How did it lead you into joining, the Ethereum Foundation?
It's a great question. I had a course in university that was about programming GPUs with CUDA. And I was like, okay, this is like very interesting. So that was back in 2016. I was like, this is very interesting. I want to see how this language is used. So I went to GitHub and looked for projects using CUDA. And the first one that I found was the ETH miner. And so I looked through the code and there was something that I didn't understand. So I looked it up in the documentation and the documentation was like, yeah, you shouldn't use this anymore. You should use this other thing. And I was like, oh, that's interesting. I sent a PR to ETHminer fixing this issue. And then they sent me, it was this open source thing. It was maintained by a guy from the Ethereum Foundation. I asked if there were any tasks or any things that need to be done. And he sent me a bunch of things that I could work on. And I didn't have a GPU back then. Basically, the development process was me just changing some code, trying to compile it, sending it to, when it compiled it, I uploaded it, I sent it to someone, and I think it was an American guy. And 4 hours later, he would reply, yeah, so this and this broke, and this is the error message. And so this went on for a week. And then I was just getting fed up with it. So I went into the store and bought the cheapest GPU I could buy, just to test it and finish the PR. But the GPU was so bad. It was a 1050 that had like an extremely loud fan. So I finished the PR. I with it for 2 days and I just went to the store and gave it back. And then later on, I bought a real GPU and became part of this team. Because I was getting interested in these kind of things, I joined a course in university on blockchain. And the professor sent a message. He was looking for someone to join his startup or like join his group. And then I joined his group and then we tried to create our own startup for 2 years doing payment and state channels. So that was from 2018 to 2020. I learned a lot during that time. The professor was very nice. He would enable us to do a bunch of really cool things. So like we talked a lot with other L2 teams at that time, Magmo, and the guys from, I think they were called L4, what later became Optimism. It was a really interesting time. I went to DEF CON Prague. That was like a real moment for me. I was meeting all of these interesting people that I've only ever saw online, and like getting to know them and getting to share some of the ideas. That was around the time we had the big proc power discussion. And because I was working on the minor, I was very much involved in that. And that was an interesting time. And after 2 years, I kind of decided I wanted to finish my master's. And I put in my 4 weeks of notice into the startup. Our company wasn't founded, but we were employed by the university to work on this. And so I put in my 4 weeks of notice. And we used Geth internally, or Go Ethereum internally, as a library for this payment and state channel stuff. And so when I left, I had 4 weeks and up to some of the stuff that I wanted to change in Geth and made PRs. And then I got an email from Felix from the Geth team who was like, yeah, do you want to join? And the email went straight to my spam folder. Fortunately, I looked through the spam folder every now and then, and I found it, and I was kind of convinced that it wasn't real, but I decided to reply anyway. And so, yeah, that was how I joined the foundation. And then I did finish my master's while working at the foundation, and I wrote my thesis almost exactly a year later on EVM fuzzing. So I created tools to test the different EVM implementations of the different clients against each other and see if they produce any differences. And yeah, I did find some. So I found 2 consensus issues, one like a class of consensus issues in Nethermind and one in Bisu. And yeah, it was a great time back then.
So when you made these fuzzing tools, did you make it from scratch or did you hitchhike off something else like AFL? How did you go about doing this?
So the idea for the fuzzing already came from Martin. He created some tools to test different EVM clients against each other. So the idea is you create a state test, which is basically a pre-state in a transaction and a post-state. And all of the clients implement a EVM tool. They call it differently in different clients, but basically you can give them the state test and they will trace every opcode. And then you verify that the opcode traces are the same. So this infrastructure to execute the test and verify that the opcodes are the same, that one was already written by Martin. And I used GoFuzz because I started out with GoFuzz and I quickly realized, okay, like this is not producing anything. This is just like, you can never have a valid call to precompile with GoFuzz. You can never have a valid call even with GoFuzz. Like you need to set up the stack. You need to set up the memory. So I created these generators that take the input from GoFuzz and do something creative with it. And so you have different strategies. For example, you take some randomness and you push it onto the stack. Or you take some randomness and you call a random address with it. This strategy was extremely good at finding very weird issues. So for example, one issue it found was if you call the modx precompile. So we have this precompile that does modulo exponentiation, basically x to the power of y modulo p. And in order to call it, you have to send it the x, y, and p, and the length of x, the length of y, and the length of p. And there was an issue that if you set the length to 0, but you don't send 0, but you send some arbitrary data, then some clients would try to execute it without checking that the parameter is actually 0. So like if you do x to the power of y mod 0 is always 0. Like if you take a modulus of any number, modulus 0, it is 0. So some clients would actually execute this like extremely complex operation. It would cost like a huge amount of gas, but in the end, it wouldn't produce anything. And so, yeah, that was one of the issues that I found back then. That was only found because I could create more complex programs. with this fuzzer.
And when you do the fuzzing, do you have to create a new one for each module component in the client?
Yes. So I haven't worked on it in a while, but back then I had, I think, around 15 or 20 strategies that do different things. The basic strategy is just take a randomness, turn it into an opcode, and execute that opcode. And that can find some stuff, but it's not very useful for these more complex interactions. So I added more and more. Right now, actually, this week I was working on it again to create some Docker files to like automatically deploy it on our infrastructure. And when that is done, because the deployment process of it was always the hardest thing, because you have to compile these tools for like these EVM tools for 5 clients, and everyone is a different language, everyone has a different pipeline, everyone uses different libraries and stuff. So my local build server just went out of date really, really quickly. And so now I'm adapting a Docker file that Martin knows when they build to create these 7 clients. Right now it's 7 clients actually. So we pushed really hard for clients to implement this so that we can just easily add them to our fuzzing infrastructure and have them have the same coverage as Geth does. That is one of the big improvements that we made over the last couple of years, is that in the beginning it was Geth and there were like the other client teams, like smaller client teams. And they didn't have the funding and the manpower to test their clients properly or like to create these tools. And so what we've always strived for is to create tools and to create test cases that can be used by all of the different clients. So they can actually focus on implementing new EIPs and whatever, and making their client run fast, and we kind of help them a bit with the security of it.
Interesting. How do you do fuzzing for like the consensus stuff as well? You mentioned you found some bugs in the consensus side process of finding that stuff.
There was consensus issues. It wasn't on the consensus side. There are a lot of initiatives to do fuzzing on the consensus side. It's actually because they have executable spec, consensus spec. It is very easy for them to create fuzzers for specific functions. So for example, in the consensus spec, there's this function that is like, I think it's called validate block or validate body or something. It is very well defined. And so there are a bunch of fuzzers built for the consensus layer. So for example, Verkle fuzz was one. It was based on Lighthouse, if I remember correctly. Another thing that the consensus layer has, or that we have on both layers, is malicious block producers. There's Mallory on the consensus layer, and I think I called it bad block generator. I'm not very creative with the names. There's something on the execution layer that also creates bad blocks. And these bad block generators, they are extremely helpful because they test just the rules around verification that a block is correct or incorrect. And we have seen this on the merge test nets. There was one issue that was found by one of the bad block generators, where basically it replaced in a block, it replaced the hash with the parent hash. And nodes would take the block, and some nodes would verify that the hash is correct. I think it was Nethermind that would look up the hash in cache and see, did I verify this hash? Did I verify this block correctly before? And because the hash was set to the parent hash, to a hash that was verified before, it would just accept the block. And even though the block itself wasn't a valid block because it wasn't hashing correctly. So these are things that are very hard to test, where fuzzers can help us quite a bit in these bad block generators.
Yeah, that seems quite interesting. If there's no vulnerability on a single client, but then you switch over to another client and there is one, then that's quite interesting because everyone might implement it differently. So there might be a vulnerability in one of them. Is there any like cross-client interactions that can cause a vulnerability? Well, just like a smart contract, you can interact with, contract A and then contract B in the same transaction. Is there something similar like that where you can do with clients? I know you can like spam false transactions to people. I think that people did that for MEV purposes to like ruin their mempools. Is there anything similar to that?
There are things where clients have to implement the same thing. And this is basically the EVM, where all the clients have to do exactly the same thing. And then there are degrees of freedom that we have. So, for example, in the engine API, there are some degrees of freedom that we have. One example that I stumbled over actually 2 or 3 days ago, Peter from the execution specs. We are on this interop and we had a really long walk and we've been running Wrath and Aragon. And what we figured out is that when we get a block, when Geth gets a block, so in the engine API, you have 2 different calls. You have new payload and fortress updated. And new payload basically gives you a block and says, this is the block, please verify it for me. Like you can execute it, you don't have to mark it as canonical. And then fortress updated marks it as canonical and says, this is the head of the chain. So what we do is we execute the block when we get it. And when we get the fortress updated, we only mark it as canonical. What REST does is when they get the block, they only verify very few things about the block. And then when someone calls fortress updated, then they actually execute the block and mark it as canonical. And so there's like timing differences there. Fortunately, it cannot be exploited, but there are different behaviors there. And it's the same thing with the transaction pool. We had this issue where Geth nodes were getting DDoSed by transactions. I think it's almost a year ago. There was a research group who came out with a paper about different attacks on the Geth transaction pool. And we fixed some of them and some of them we didn't. And at some point, someone saw this paper. The paper was published and they made a PR and someone saw this and started attacking Geth nodes. And because Nethermind had implemented the transaction pool in a different way, they couldn't be attacked. And so everything still worked fine, even though some Geth nodes would not have the transaction or wouldn't have many transactions in their transaction pool. They would still create blocks and Nethermind would create.
If I wanted to so what were these attacks? And the only reason they didn't get exploited is because the mind implementation was different, right?
Well, they did exploit it, but it was only for like a couple of hours. We saw this and we knew exactly what was going on. And we did have a kind of stale branch that had the fix for it. We just never really bothered merging it. And so we just verified that it was correct and that it stopped these attacks. And then we merged it and then asked everyone to update to the newest version who was affected by it. It wasn't a big deal, fortunately. So if there's an issue in these surrounding areas where we have certain degrees of freedom, fixing it is usually extremely quickly. An issue in the EVM and consensus finding it's a very different beast.
So what are like the main areas that people modify that you notice?
Usually the last 2 or 3 years ago, other L1s would fork Geth and modify the consensus. So they would leave everything as is and they would just go in, replace the Ethereum with like their blockchain name, which would create a very interesting issue because we have a protocol, the networking protocol of Ethereum is called ETH. So we have ETH 65, ETH 66, the different wire protocol versions. And they would rename this to whatever. I think there was Polygon did it, and it was BOR 66. And we had one check that said if we have this other protocol enabled, Snap, and we have a protocol that is enabled that is not ETH, then we would spit out a warning. So there was a time where Geth nodes would warn all the time because people would try to connect to them from a node that was not on an Ethereum node, but a Polygon node or other nodes. And nowadays, there's been a big push of L2s roles to be based on Geth. And so people there, usually they're also modifying the consensus a bit, but they often add system transactions. They're adding precompiles because a precompile is like the easiest way of getting your code into the EVM. And you're still EVM compatible. You implement the same opcodes, the smart contracts that work on mainnet will also work on your rollup. You're not really modifying. And then there are the MEV people, and we don't really see a lot of changes from them being upstreamed. Sometimes we see some stuff, but they don't want to lose their competitive advantage, which is pretty sad in my opinion, because like they're extracting a lot of value from the ecosystem, from us, and they're not contributing back. And that is kind of sad. So if you're an MEV person, you're getting out of the game, upstream your changes. We might even have a job for you. And I think those people, we have like a bunch of guardrails in place, just sanity checks, things that we compute that don't really need to be computed, but it's always good to check it twice. And they remove those to be the fastest one, to be the quickest one.
Right. And probably like integrate their own searches into the nodes as well, so you don't have to do all these API calls and whatnot.
Yeah, exactly. Yeah, exactly. Just having the marshalling and unmarshalling via the JSON RPC is so costly that it makes no sense to use it. And then there are some people who like send something or complain about something that probably most likely MEV people or builders, but they're using the JSON RPC, and I'm like, if this is really what you're doing, then I don't think like you're doing the right thing. So
yeah, I think if you want to be competitive, you got to put it all into the node itself, get as granular as you can, because like every little bit counts basically. What do you think are other kind of modifications people can do to make it a lot faster or more efficient in any way, since that's what you're kind of focusing on with performance nodes?
So one thing that we realized yesterday, we had a great discussion yesterday, and we realized that we have the Bloom filter. Every header has a Bloom filter for all of the logs that are in this block. And every transaction has a Bloom filter for all of the logs that happened within this transaction. These Bloom filters, if you add them up for all transactions, for all receipts, they add up to over 500 gigabytes. It's crazy. It's only Bloom filters. It's only 8 bit sets. And for like nodes have realized this a long time ago, that it doesn't make sense to store them. Like we store them for the header chain, but we don't store them for the transactions and for the receipts. And so all nodes have dropped this 500 gigabyte data set. But if you start a node now, you will ask for the full block. You will ask for the full receipts. That means that the peer that you're asking this from will pull up the receipts, will pull up the block, and will create the Bloom filter on the fly, send it to you. You receive the full thing with the Bloom filter. You yourself will verify that everything is correct. And then you will throw away the Bloom filter because you store it without the Bloom filter. That means you induce a lot of work on the other side to create the Bloom filter that you are going to check anyway and that you are going to throw away in the end. And you have an additional 500 gigabytes of bandwidth that you need to sync a node. So every node has like in addition to the 600 gigabytes of history, you will sync another 500 gigabytes of these Bloom filters, which is crazy, just to throw them away. And so what we're thinking right now is to create a new protocol version where we just don't send the Bloom filters, because it makes no sense to send them, like to recreate them, send them, and then throw them away.
It's a bit inefficient, just a little bit.
Yeah. And it's like every node that syncs needs to sync those 500 gigabytes. And it's kind of stupid. And we would also love to remove it from the header, because if we do that, the header would be reduced by almost 50% from 508 bytes to 50 bytes or something. Basically, the header chain, the size of the header will almost half. And so the header chain will almost half, at least for the coming blocks. So for the future. And that would mean we would, like, if you run a light client, you would only need to like get half of the data. So yeah, those are things that are still in the protocol and no one really like kind of figured that out. And there, but those are protocol-wide changes. And we also discussed a change to the way we do the trie computation that might actually make it quicker. But this is something that you will save maybe 2 milliseconds, maybe 5. And at this point, it's not worth it for us, for Geth to implement it. It might be worth for other people to do it because they want to save these 5 milliseconds, but for a normal node, it wouldn't be worth it.
Definitely. If you're not going to implement it, what actually is it?
Or you want the juicy alpha. So it's not that easy to implement. You need to be a reasonably good developer to do it. If you did it, send me a message. That would be really nice to see if actually like how much the difference would be and if it can be done. So basically you have in the header, you have the transaction root, right? This is the Merkle-Patricia root of the transactions. What you do with the transactions is you insert them with just the index encoded as RLP. So basically the trie that looks like if you have two blocks, one block with transaction ABC and another block with transaction DEF, the structure of the transaction trie is always the same as long as there are the same number of transactions in it. So what you can do is there's not that many different numbers of transactions in a block, right? You can have 1 transactions, you can have 100, and you can have like, I don't know what the max is, like 500 or 600 transactions per block or something. So you would just pre-compute the structure of the trie, and then you can insert the values that you want of the transaction hashes and then hash it all together. And that would be way, way quicker than what we're doing right now is we start with an empty trie, we insert the first transaction, then we insert the second transaction, and we build up this trie. One optimization would be for someone to go and say, I have this 127 transactions, so I pick the pre-computed trie structure with 127 slots, and I'll insert the transaction hashes, and then I hash it together. The thing is, creating the transaction hash is dominated by the hashing itself, not by the construction of the trie. So that's why I'm saying it's most likely only a very slight improvement over what we have right now, and it would make the code quite a bit. You need to pre-compute everything up to 1,000 transactions or something. You would need to fall back to the normal trie for everything above that, and you would need to create the thing how to cache basically the trie structure.
I've always been thinking about whether you need everything in the block, or you could just have small select part of it, the essentials basically. Or could you really just take like a few things and have the essentials and then get rid of everything else to avoid all that computation? So kind of like a bare bones node.
Yeah, we recently had this issue where a builder would propose bad blocks and not realize that they propose bad blocks. One thing where you cut corners in order to improve your performance, but at the cost of security, basically, at the cost of the health of the network. And I know people are trying to make money, but I think it's way more important that the network actually stays healthy. And yes, you can not validate the block that you get and just build on top of it or something. But that would mean that potentially one bad block would induce a series of bad blocks, or we would have these bad block sidechains or whatever. And it's dangerous out there, so tread carefully, I'd say. Sure, it's possible to remove some of the checks that we do. At what costs?
Yeah, for speed. You're removing security, of course. What are your thoughts on Ref, the Rust Ethereum node?
I'm not a Rust developer, so I cannot really speak to like their code or what I really like the team. I really like Draga. I've met him a bunch of times. He's been extremely nice to work with. Also, I met a bunch of the other Rest developers, and they seem extremely bright. What I like about it is there's a big company behind it, so there's a bit of firepower, and I think they're capturing a lot of minds with it. So there's a lot of people who are interested in Rust development, and like Rest is one of the coolest, newest projects in Rust to work on. So there's a bunch of Rust developers and there's a bunch of Ethereum developers that get nerd sniped by it. And I think it's really good. I think that's really healthy. I'm hoping that they're in it for the long haul. I think sometimes people kind of announce clients or like start work on clients, and when the like initial work is done, they don't want to go into the maintainer mode. So they are hackers, they are builders. In order to be successful as a client team, you have to be maintainers. You have to have this maintainer mindset. And I hope that when the initial development, like all of this exciting stuff for REST is done, that they can then switch into this maintainer mode and maintain the client.
Well, since maintaining is such a important thing, how do you become a great maintainer then?
I don't know. I'm not a great maintainer.
Oh, God.
No, Peter is our team lead. He's a great maintainer. You have to be strict about what you let into the client. We get really interesting and we get really stupid feature requests. And you have to be very careful about what you allow into the client because you have to maintain it forever. So, for example, we have the personal namespace that was included into Ethereum nodes because of the Mist browser back in the day. Basically, Fabian Vogelsteller worked on the Mist browser and he wanted to connect to a Geth node or to an Ethereum node and let the Ethereum node sign transactions. So we have a key store because of this. Like you can have your keys unlocked in your Ethereum node. No one needs this. No one should have this. No one does this. But it's still used by someone out there. And so we cannot remove it. And it gives us so much headache because we even have, for this key store, we have USB support. So we need USB support in the clients because you can connect your hardware wallet to this key store so you can sign transactions over the personal namespace. All of these things, no one ever does. But if we remove them, someone will start to complain. That's the thing about a great maintainer is you have to be able to differentiate the useful features that are useful for a lot of people from the non-useful features. And then you also need to see, are these features going to stay? Are these features worthwhile to maintain over the long haul? How are they introducing new complexity into the code? Can you maybe factor them out in a way so that they don't introduce this complexity and you don't have to maintain, like keep this complexity within your code or have it as an optional module, have someone else maintain it. And so these are the kind of the things. And it's very hard to find great maintainers. And you have to be nice to people on one hand, but you also have to be strict on the other hand, to not just say, yeah, sure, let's do this, let's everything and let's merge this horrible looking code. We might actually be able to fix it up afterwards and no one ever does.
Interesting. How do you see like Ethereum progressing from here? We had proof of work to proof of stake merge in like 2022 and like following MevBoost and all this other stuff. And those are like really big things. So where do you hope to see Ethereum goes in the future and how should people kind of upskill for this or work towards building this?
I really like this idea of Ethereum being the settlement layer for other things and having this decentralized validator set that doesn't censor, that doesn't create weird things, that follows the rules and that people can rely on. And I think this is one of the big advantages of it is it's clear that it's stable. It's not changing. There are a lot of issues with Bitcoin because it's not changing. But one thing is like can be clear that it's the same thing in like 5 years. And I hope we will at some point be at this place where we can do this ossification of Ethereum. Then Ethereum needs to be perfect. Like, it makes no sense for me to ossify something that is not perfect. And I think that is the biggest problem of Bitcoin, is that they ossified something that is not perfect. I think we'll need a few more years, probably quite a few more years until we get to this point. But I think that we're slowly moving in this direction where we're actually thinking about what will be the end state of Ethereum.
What do you think the next step is then?
So I'm a big fan of Verkle. Guillaume from our team has been working for almost 2 years on it now, and it looks really good. We did have a light client in Geth that was working, LES, up until the merge. It unfortunately got broken with the merge, and we removed it. But right now, we're actually, Jolt, Felix from our team are working on introducing the light client. We have a beacon light client, so we can follow the beacon chain. And then we will also create a light client that you can verify proofs from. So someone sends you a proof that, I don't know, this is the balance of your account, and you can see, okay, yes, this proof is correct because I can follow it to the block header and I know that the block header is correct. But then you're still relying on someone to create these proofs for you, a full node, a server. And what it enables us is we can trustlessly follow the chain. Someone would send us a block and they would send us a witness, and we can verify the witness and see that this block was actually correct. And I think that is extremely powerful because right now we have maybe 10K, maybe 15K nodes verifying the Ethereum blockchain. And with Verkle, we can scale this up, hopefully 10x, 100x. So I have like hundreds, thousands of nodes verifying that the state transition is correct. That would be really, really good. And then we can also have these, basically right now, if you send a transaction with your wallet, you're trusting your RPC provider that they don't do anything weird. So your funds correctly, that they create a transaction for you correctly. I would hope that in the future we will move to a space where your wallet actually verifies the blockchain and your wallet actually buys everything that you do. It's all cryptographically secured. So every wallet should be its own light client, in my opinion, in the future.
Definitely. Just like how ChatGPT could be pre-installed into an iPhone, for example. And just to pivot just to this final questions, if you were to restart your career, would you pursue anything differently? Or do you have any advice for people pursuing their careers now? And what were some of the most impactful mistakes you did that people might come across?
That's an interesting question. I would do the same thing over again. I don't really regret anything, except for maybe being too harsh to some people some points because I was myself overworked. But from my actions, I don't regret anything. They all led to the point where I am right now. When I left the startup, I did have some thoughts about did I leave too late? Did I leave too early? I learned so much working with the people back then that really set me on the way. Biggest mistakes, I do have this character flaw where I'm a bit too hot-headed. So there's been times where I was aggressive in discussions. And one thing that I really liked about Ethereum from the beginning was its people and its community. I took it for granted in the beginning, and it's not. And there's a lot of communities out there that are not as nice to be in as the Ethereum community. And I think it's very important for everyone to actively strive for that.
Yeah, I've recently noticed this as well. Being calm in every situation is super important. I was getting a little bit hot-headed as well, I think last year, but no reason, very simple reasons. Maybe it was, I don't know. Yeah, at the end of the day, I think it's super important because just communication alone changes the trajectory of things. It just takes one mess up and it can screw everything up. So I can relate.
It's not bad if you mess up. You just have to apologize, and people will accept your apology. And if you try to do better, it will be. One thing I noticed is I'm trying to help as many people as possible. So if people like come to me and send me something and be like, oh, I want to propose this EIP, can you take a look or something? I will try to help them. And unfortunately now cannot do this as much anymore as I used to because I just have so much other work to do. But a bunch of people that I've helped in the past have ended up becoming really, really great developers, really, really good people, and contributed great things and has helped me on my way after I helped them on their journey. So I think that that's something that I would encourage everyone to do is like help other people so you will see that they can create great stuff and they'll help you out.
Yeah, pay it forward. Well, man, I super appreciate you coming on, and I think I've learned a lot, and I'm sure a lot of people learn a lot and look back at this and be like, oh, just like how I started my MEV journey, I was listening to like MEV Senpai, and it's like a defining moment. So I think it's hard to find conversations like this, and I'm hopeful that people will find a lot of value in this. So Marius, thank you so much for coming on. I really appreciate it.
Yes. Thank you so much for having me. It was great talking to you. And I hope that your listeners took something away from it, even if it's just like, don't be an ass. I think it's a great message.
Definitely, man. I'm sure we'll have another conversation in the future. But until then, everyone take care.